Hello and welcome back to Physics Safari. My name is Abhishek and today I'm going to discuss the graph. But before I go into the graph, let me ask you a very simple question which completely depends upon your IQ and your common sense. Okay, so let's try and answer that question and I would give the answer towards the end of the lesson. Okay, so let's suppose we have a situation where there's a long bridge. Okay, it's a long bridge. It's a very, very long bridge. It has a certain capacity beyond which, even if let's suppose 100 grams also increases, the bridge would collapse. I'm repeating, even if 100 gram more than its capacity mentioned comes on this, it will collapse. Now the thing is, there is a truck with its driver over there. There is a truck with its driver, and its weight is completely equal to the capacity of the bridge. The weight of this, the weight of this truck along with the driver is exactly equal to the capacity of the bridge. Now, the truck was going. It was almost about to reach the other side of the long bridge. It was almost about to reach the other side of the long bridge. But then an eagle came and sat on the bridge. And you must be aware of the fact that eagles, the weights almost equals to 1 kg or 2 kg probably. But the eagle sat on the truck, still the truck managed to cross the bridge and the bridge did not collapse. You getting my point? So the weight of the truck is equals to the capacity of the bridge. It was a long bridge, it was going and the eagle came and sat on this truck when it was almost, it was about to reach the other end of the bridge, but still it crossed the bridge. Now you have to answer how it was possible. Driver did not jump out of the truck. The truck crossed the bridge along the driver. Alright? So you try this and if you get the answer, do let me know in the comment box. I'm going to answer this towards end of the lesson. All good? Fair enough. Now, having said this, let us start with our physics topic, that is the graph. And everyone knows graph is so damn important when it comes to the physics and the Jee questions. Graph play a very, very important role in the Jee. Not just on the kinematics, Jee tests you on the graph in various topics. In various topics, the Jee will test you on the graph. So do learn this topic properly. And if you need to pause the video and sort of process the information, do not hesitate in doing that as well. You pause the video, understand, rewind the video if it is required, and understand, and then only move forward. All good? Now, let's say if I talk briefly about the graph, we could be facing around few graphs like xt, vt, at. Also, we can have speed time graph. We can have distance time graph. We could also have position velocity graph. We can also have position acceleration graph, so on. If you remember, I mentioned in the previous lessons that we have 36 whole relations. So graph could be asked on any of those. Broadly, we're going to talk about these terms. Types because the majority of the questions will be relevant to this. And if you could grasp all these things properly, I'm sure you will be able to translate that graph to any variables. Now, going further, why the graph is so important? Look, there are going to be so many questions in the Jee exams where you need to do a lot of calculations and you end up wasting a lot of time, spending a lot of time, I would say. But in the graph questions, you can actually answer within a quick span of time, and you can save more time for the questions that actually demands more time, because all the questions will not be demanding equal amount of time. So you can save the time on the graph questions if it clicks to you, and then you can utilize those time probably in the another questions which are more calculative in its nature. Energy? Badhiya. So let's say the kind of graph that we'll be talking, as I mentioned, okay, the duster has become a bit dirty. Okay, now, broadly speaking, there are going to be two situations with the graph question. One is that when the graph would be given and you have to do the analysis of the motion. All good? And the second case is that the motion would be given, its parameter would be given, and you will be asked to draw the graph. Okay, so let us first see some situations of the graph, and then we're going to see some given parameters, and then we're going to draw the graph for those parameters. ठीक है ना जी? बढ़िया. So let's see the two things that you must be careful and must be aware of, that in graph we're going to discuss about the slope and the area. Slope and the area. And these becomes even further more important if these two represents any physical quantity. If these two starts representing any physical quantity, then it becomes sort of more important. So we're going to see what the slope of various graphs and what the area of various graphs gives you. Does it give you any physical parameter? I mean, like physical quantity? Yes. Then we're going to discuss more about that. All good? Now, so if I say slope, I have already discussed about the slope in my previous videos. You can watch them. Let's suppose I have some graph xt, and there is a graph like this, somewhat like that. So its slope is going to give you what? Slope of xt graph would give you the relation between, let's suppose this is small delta x and this is delta t. So slope would give you what? Delta x upon delta t, which is nothing but the velocity, which is a physical quantity. It becomes important. It means the slope of xt graph becomes important. Area of this would give you nothing. On other hand, if I have a graph between, let's suppose velocity and time, okay, its slope will give you what? Slope of velocity time graph give you change of velocity over change of time. That means delta v upon delta t. That would be nothing but your acceleration. So slope is going to give you what? Acceleration of vt graph. Whereas the area under vt graph, area should give you what? Area would give you displacement. Area would give you displacement. See how important is this vt graph? I would say this is the most important graph in this graph for the xt, vt and at. Because both the slope and the area gives you certain physical quantities. One is giving you acceleration, another is giving you displacement. So this becomes further important. Likewise, if I have, let's suppose, at graph, if we have at graph, somewhat like this. Now, slope gives you jerk, which is not in your syllabus, so that is okay, you can ignore that. It gives you jerk, by the way. Now, area gives you what? Area gives you velocity, right? Area gives you velocity. Well, this is wrong. Area does not give you velocity, it's a misconception. Area gives you change in velocity. Area gives you change in velocity. I hope this part is coming. Yeah, it's coming. Very good. So area gives you change in velocity. Why? Because if I talk about the area, if you know the acceleration is how much? dv upon dt. So a into dt, a graph into dt graph should give you what? dv. So area under at graph gives you the change in the velocity, not the velocity itself. So just be careful about this, no? Okay, great. If you want to note down something, you can actually note down. Now let us deal with some graph given, and we're going to try and analyze that graph that in various situations, in the various situations. So let me just erase it. Okay, so here we have, let's see certain graphs, and we're going to deal with them one by one. What are the physical quantity that they are reflecting to you? All good? Chaliye, badhiya. Now, let's say in a very simple thing, if I have a graph, of, let's suppose, your x and t, if I have the graph of, let's suppose, xt, and let me use this color, okay, and the graph is given like this. The graph is given like this. What could you interpret from here? You can see that over a time period, this displacement remains constant. Means with the time, the body's position is not changing. It means this represent the body at rest. ये rest को दिखा रहा है ना जी? Now on the same, if I look at any vt graph, and let me draw another parallel line here itself. Okay. Now does it reflect the body at rest? Yes or no? The velocity is constant. Does it mean that the body is at rest? No, certainly not. It is moving with a constant velocity. So this represents uniform motion. and you people should be taking it as acceleration is equals to 0. All good? So when we have the graph like this, it's going to be at uniform motion at 0 acceleration. Energy? Okay. Now let us say that if I have more like AT graph, and this is a line, okay, AT graph. Does it mean that body is at rest? Absolutely not. What does it mean? It means that acceleration is a constant value. Now if acceleration is constant, and you can see it is coming in the upper side of this time axis. It's in the positive side of the acceleration axis. It means it is showing you a positive acceleration. It is showing you a positive acceleration, which means the velocity would increase. These are the minute information which I want you guys to learn how to capture those things, how to capture those minute informations. So yeah, a couple of things I mentioned. When the graph of xt is parallel to time axis, it means the body is at rest. Now, when the graph of velocity time axis is parallel to the time axis, it means the body is moving at a constant velocity, that means 0 acceleration. Whereas, if the graph of AT is parallel to time axis, it means the acceleration is constant. That does not mean the body is at rest. Acceleration is constant, which means the velocity is increasing, and moreover, the acceleration is positive. It means the body is accelerating and the velocity is increasing. All good? Now, let us deal with this xt graph in little detail. तो xt graph को और अच्छे से समझते हैं. Okay, so let's say if I have xt graph, and I would say straight line. Let's suppose it's starting from origin and going straight line. मेरी बातों को ध्यान से सुनो. Listen to me carefully. As you could see, I know that slope gives what? Velocity. I'm using x for the displacement. Slope gives you velocity. For a given line, the slope will remain same throughout. It means it is giving you a constant slope. Slope is constant, and which is equals to velocity. That implies velocity is constant. That also implies acceleration is 0. That implies acceleration is 0. It means body is moving at a constant speed. At time t is equals to 0, the slope is positive. Very important point. Please note down in your notebook. At t is equals to 0, slope is positive. All good? Slope is positive. It means the body is moving away from the origin in positive direction. Positive direction means towards right. So basically this is a situation that object is moving in this direction with a certain velocity v, which is going to cover the uniform, equal distance in equal time interval. Energy, all good? Okay. So this is one interpretation that you guys can note down. Now let us move on to the second interpretation. Of the graph of xt. Look, xt again is a very important graph. We're going to learn it properly. Then we're going to move to vt and at. Okay. Now let's say the second graph. Second situation. This was the first situation. Already I mentioned 3 when the line was parallel. So I've discussed the parallel thing separately. Now I'm dealing with this straight line. And the second one I can talk about is, okay, let's say here we have the graph of xt. And the graph is like this. The graph is, maybe I can say like that. As our, okay, understand this one. At time t is equals to 0, slope is positive. Now how to understand if the slope is positive or not? Simple, easy technique. Just draw a tangent and see if it is making an acute angle or the obtuse angle. If it is making the acute angle, theta less than 90 degree, it means the slope is positive, because we know slope is what? Tan of theta. And if theta is acute, tan will be positive, resulting m as positive. But yeah, at time t is equals to 0, slope is positive. Okay, that means body is moving towards positive direction away from the origin. Body moving in positive direction, that is away from the origin. If this is origin, the body is moving in this direction. Simple है ना, बहुत अच्छे. और समझते हैं. Let us take these 2 points, let's suppose P and Q, under consideration. It is xt graph. So let us draw a tangent. Let us draw a tangent over here. See this tangent. Let's say this is theta 1, and let us also draw a tangent over here. Let's say that is theta 2. I believe you guys would agree that slope at point Q is going to be more compared to slope at point P. Reason being, theta 2 is more than theta 1. That means tan of theta 2 is more than tan of theta 1. That means slope at point, let's say Q, is more than the slope at point P. That means if I look at the rate of change of slope, ध्यान से सुनना, if I look at the rate of change of slope, I should be getting a positive value. Rate of change of slope, rate of, ध्यान से सुनना, rate of change of slope is positive. Now, rate of change of slope means slope is what? Dx upon dt. Rate of change of this, that should be dt of dx upon dt, and this is positive. Why? Or you can say like this. चलो लिख लेते हैं इसको. Final value minus initial value. Final is more. Slope is higher at point Q compared to slope at point P. It means that would give you a resultant as positive. Simple as that. Now, this is nothing but d square x upon dt square, which is more than 0. And my dear student, you understand that double derivative of x with respect to t gives you what? Acceleration. That means acceleration is positive. Very important fact. Very, very important fact. You can see that the graph is giving you slope, rate of change of slope as positive, which means it is going through a positive acceleration. Positive acceleration का meaning क्या हो गया? Towards right. Towards the right. And over here the velocity also is towards right, because at initial point time t is equals to 0, the slope was positive value. It means the body is moving towards right. अब देखो situation क्या है जी? The body is over here. Let's suppose time t is equals to 0. Body's velocity is towards right, as well as the acceleration is also positive, that is towards right. It means body will keep on accelerating. The body will keep on accelerating. This means the velocity would be increasing. The velocity would increase in the positive direction. इस बात को ध्यान से सुनना. The velocity will increase in the positive direction. Velocity is not going to be at any decreasing point. ये हमेशा बढ़ता रहेगा. Let me quickly recap that. What are the process that we should use? We should adhere to understand the graph. First of all, figure out if the body is moving towards right or moving towards left. How do we know that? At time t is equals to 0, find the slope. If it is positive, body moving in the positive direction, that side. Now understand, if the graph is not straight, as we had seen in the previous case, where the graph was straight, it means it was moving at a constant, I would say, velocity. There was no acceleration. But here, the slope is also changing, and slope is increasing with the time. Slope is increasing with the time. And that means rate of change of the slope is a positive value, and rate of change of slope is all about acceleration. And if acceleration is positive, that means the body is having acceleration along the velocity direction, which means the velocity will keep on increasing. The velocity will keep on increasing. Note down. इसको note down कर लो जी आप लोग. Note down this information. So what we need to understand is the velocity is positive or negative, acceleration is positive or negative. चलो अब चलते हैं सेकंड सिचुएशन पे. Let us clean this up. इसको will clean this. I hope you guys have understood this point. समझना धीरे धीरे, slowly we'll understand and we'll take it to the little higher level step by step. Then we'll do some questions which was asked in the JEE in the previous years. है ना? इसको हम लोग आगे बढ़ते जाएंगे. अब देखो, let us see a situation. Suppose again I'm going to draw the xt graph. ध्यान से just be careful. ध्यान से देखना. Okay. Let's say the graph is like this. Graph is like this. ऐसा कुछ. This is your time axis. This is your displacement axis. Well, the time over here is t1, 0, and let's say t2. ऐसा कुछ देखते हैं. First of all, understand whether the body is moving towards right in the positive or towards left. So, at time t is equals to 0, at time t is equals to 0, let us draw a slope, and that is going to be positive, positive. It means body is moving towards right. The body is moving in the, that means body is moving in the positive direction. Body moving in positive direction. अच्छी बात है. Point number 2, what we need to figure out, whether the body is accelerating or deaccelerating. Simple सी बात है, it is a curve, तो there should be some acceleration or deacceleration. Constant velocity तो होगा ही नहीं. It is not going to be a constant velocity. So we need to understand whether the acceleration is positive or negative. Simple तरीका, what do? We take 2 points. And we try to figure out the slope. Why? That would help you to understand the rate of change of slope. Let's suppose this is point P, this is point Q. So at point P, if I try and draw a tangent, let's suppose that should be somewhere like this. And point Q, you can see, if I draw the tangent, definitely theta 1 and theta 2, it is quite evident that theta 1 is more than theta 2. Achhi baat hai. That means tan of theta 1 should be more than tan of theta 2. That clearly means that initial slope is more than final slope, as in point P and Q, taking the initial and the final points. So change of slope would be negative because final जो है is less than the initial. That clearly tells you, my dear everyone, that d square x upon dt square is lesser than 0, which is nothing but acceleration is less than 0, and this is happening till time t1. So this is the motion that we are considering till time t1. Till t1, what we have said, what we have seen, the body started moving in the positive direction, but with a deceleration. The body is retarding. The force is, acceleration is in the negative direction. So situation कैसा है जी? So this is the situation that is prevailing. Body is moving towards right, no doubt, but the acceleration is negative. Acceleration क्या है? Negative. It means the acceleration should be towards left. Acceleration rest left की तरफ है. Well, if a body is moving in one direction and the acceleration is in opposite direction, the body has to come to rest. In some time, not in 2 seconds or 5 seconds, but it will come to rest for sure because the force is against the motion, So the body would come to rest. Okay. So what is the condition for the rest? So यहाँ देख लो, condition for rest. Condition for rest in xt graph. In xt, हमने देखा था initially when the line was parallel. Do you remember when the xt graph, when the line was parallel? This is your x, this is your t. So displacement was not changing. It means the body was at rest. हमने देखा था, already we have seen. Look at this point. Look at this point. If I draw the tangent is parallel to the x-axis. It means at time t1 over here, the slope, that is dx upon dt, is 0, and for xt curve, dx upon dt gives you velocity. Velocity is 0. Okay, it means after traveling for certain time, the body would come to rest. So at time t1, the body would come to rest. Itna to clear hai ji? All good? The body is at rest at time t is equals to t1. Let us understand what's happening next. If you again choose the 2 point, let's suppose you choose this point and maybe you can choose this point. At this point, if I draw a slope, it is going to be a negative slope. Negative slope means the acceleration is in the negative direction. Quite clear? And it will be having some value. If you draw the tangent over here, see this, its angle is sort of decreasing. Its angle is decreasing. Clear baat hai na? The body is having some negative acceleration and it is decreasing over there. See this, rate of change of slope is negative over there. This is lesser slope, this is the greater slope in terms of the magnitude. Hai na? So what we have understood from here that after point T, d square x upon dt square is again negative. It means acceleration is again towards left only. Acceleration is, you can say, it's a negative acceleration. It's a negative acceleration, but it is but you can say that after point T, you know, still it is a negative acceleration. So what happens over here? The body would come to rest over here and it will start moving in the leftward direction. So in this case, again the velocity will be increasing. Here the velocity was decreasing. Reason being, acceleration was opposite of it. Energy. And over here the acceleration also is acting in the same direction of the velocity. It means velocity will keep on increasing in the in the opposite direction. So the body will come to rest. If I am looking at this graph, the body will come to rest. Displacement will be positive. The displacement is above this axis, so displacement is going to be positive. We are not facing any negative displacement as of now. Okay, I know the body is coming to sort of the same position, but it is not going backwards. It's not going to be the negative displacement because it is above this axis. So be careful. Displacement will be positive. जो भी होगा अपना इधर ना. So it went and came back. So I mean, like finally it will be zero. Net displacement will be zero, but it is not going to be negative. वो positive ही रहेगा throughout the journey. If I'm looking for the time, anything little beyond zero and anything little beyond this point where it comes back to zero, the displacement will be positive only. अपना positive side में रहेगा. All good? So let's quickly recap this, what we have done. If the graph is like this, it's all about deceleration. So we can conclude that, simply yaad rakhna, just keep this in mind. If the graph is like opening upward, we'll be having positive acceleration. When the graph is like this, we will be having negative acceleration. इतनी बातें तो क्लियर है जी? ऑल गुड है ना? बढ़िया. चलो थोड़ा आगे और हम लोग बढ़ते हैं. नोट डाउन कर लो इसको. नोट इट डाउन. Just note it down. All right then. Okay. So we have seen few cases where the graph was opening upward like the open ball, and when it is inverted, you can say it's a inverted ball. In that case, we will have the negative acceleration. एक question से समझते हैं. We'll do more question. I would be making at least 2 videos lesson on this graph. आज थोड़ा fundamental समझते हैं. In the next video, we will do more practice questions on this. We will do more practice questions. Let us take an example. Let's take an example. Let's say if the body was thrown in the upward direction with certain velocity u. The body is thrown in the certain upward direction. Now we're going to see the second part of the graph where we'll be given a situation and we have to draw the graph according to that. Okay? Okay? So let's suppose body goes up and it comes back. Okay, good. Now understand one thing. To draw the graph between the two variables, we must have the mathematical equation between the two variables. अपने को equation होना ही चाहिए to be able to draw the graph. अच्छा, let us understand the xt graph. We all know that the height will be how much? Height will be u square upon 2g. The total time of flight will be 2u upon g. Time, let's say t1 while going upward is going to be how much? U upon g, and the time that it will take to while coming down should again be u upon g. Let's suppose it takes time t2 to come down and t1 to go in the upward direction to the maximum point. Now we all know that h is given as what? Ut minus half gt square. Ut is equals to half gt square. Don't you think this is representing a quadratic equation? How? It's going to be how much? Negative 1 upon 2 gt square plus ut minus h equals to 0. It is a quadratic in t with a negative coefficient. एक negative coefficient के साथ it is a quadratic in t. Quadratic equation represents a parabola. And since its coefficient of t square is negative, it should be inverted parabola. It should be inverted parabola. Already we know this. I have discussed about this in the basic mathematics. है ना? ये हमने बता रखा already. Now, if I look at it over here, let's draw the xt graph. हम लोग xt graph से start करते हैं. Let's say I have the xt graph. This is your x. This is your time t. At initial position, time t is equals to 0. The body is on the ground. That is, the displacement is 0. Now, as we go up, the velocity will decrease. Displacement would increase. Acceleration is negative, downward, always. So see, few things that you must know. Acceleration is negative. Displacement is positive because it is above the ground. And if you take the earth as origin, ground as origin, it's going to be positive. So while going, we have a negative acceleration. And just now I've told you, negative acceleration means the graph should be like this. And when it reaches at the top, velocity becomes 0. Tangent should be parallel to x-axis. When it starts coming, acceleration still remains negative, downward. So the velocity would increase, but the accelerations would be negative. So this is how the graph should look like. This is how the graph should look like. Now, at what time it's going to be at the maximum position? Time t is equals to u upon g. And this is going to be time t is at 2u upon g. And this height, which is obtained, is nothing but h will be equals to how much? U square upon 2g. If you want to get back to this situation, you can understand at time t is equals to 0, slope is positive, body is moving in the positive direction, and for the vertical motion, we choose upward as positive. Do you remember? You know, and the negative we choose in the downward direction. So it is going to be how much? Positive. It is the acceleration is decreasing. Sorry, the velocity is decreasing because we have a negative acceleration because the rate of change of slope is negative. At the top, as you can see, tangent is parallel to ground. So at this point of time, the velocity is 0. Already we have seen that. Now again, the velocity would increase in the negative direction. It is coming back to the ground. It's coming back towards the origin. Remember this? Went and came back, you know. And it will take equal time to come back. Already these things we have discussed. Okay, now for the same situation, let us draw the VT graph. VT graph you know draw kar lete hain. Let us draw the VT graph. So to draw the VT graph, we must have the relation between the velocity and the time. है ना? We must have the velocity and the time relation. देख लो. So V is equals to what? U minus GT. So I could write this as what? V is equals to minus GTU plus U. है ना? थोड़ा और अच्छे से लिख लो इसको. Make it more clear, more visible. Okay, we know that equation of straight line with some slope M plus some intercept c, don't you think these two are resembling each other? Velocity being the y-axis and you can say the time being the x-axis. Slope is negative. At time t is equals to 0, velocity should be how much? At time t is equals to 0, velocity should be how much? U, some positive value. It means it is going to intercept over here. At time t is equals to 0, it should have some initial velocity of u. Slope is negative, means like this one, you know? And it is going to represent a straight line. This represents a straight line. Please do not forget this. Straight line. Velocity time graph, straight line. It's coming to here. At the top point, in certain time t, the velocity becomes 0 over here. The velocity becomes 0 at the top point. At what time? थोड़ा इसको आप बड़ा कर लो. Increase the length of time axis. Let's keep it here till here. You know, ठीक है. At top point, after the time how much? This time should be equals to how much? U upon g. The velocity would become 0. है ना? Now, is the motion completed? No. We only have reached till this top point. After this, what's going to happening? Is the acceleration changing? Is or does acceleration change at top point? Does it change? Answer is no. Answer is no. Very important concept. Okay. Does the acceleration change at the top point? No, it's still minus z. That means, that implies that slope won't change. Slope won't change. It will go in the negative direction, because after this the body is coming down, velocity is downward, so negative. But the slope does not change, my dear. It means भैया ये हो जाएगा आपका नीचे, but the slope will not change. ध्यान रख लो, the slope will not change. Yes, the velocity is in negative direction. अच्छी बात है. The velocity is in negative direction. I agree with that. But the slope would remain same. And it will come back to the surface in how much time? T will be how much? 2u upon g. And when it is going to touch the ground backward, its velocity is going to be minus u. Its velocity is going to be the minus u. This is your VT graph for this particular situation. Clear है जी? Velocity graph should be this one. चलो इसको कर लो भी note down. Please note it down. Note down everyone. हाँ जी. Let us draw the acceleration time graph now. उसको भी कर लेते हैं. So let me make some space over here. If I want to draw the acceleration time graph, if I want to draw the acceleration time graph, AT, ठीक है ना जी? Throughout the journey, what was the acceleration of the object? It was of course how much? Negative g, है ना? वो तो change नहीं करा. That did not change. So the acceleration time graph for this particular situation should be like this. This is going to be negative g, and that's going to be constant throughout. और पूरे टाइम पे रहेगा जी आपका constant. So we had seen some few informations about few situations of the graphs. xt graph का हमने देखा when the acceleration is positive, when the acceleration is negative. जब भी acceleration is positive हो, graph ऊपर की ओर open रहेगा. It is going to be open upward. And when we have the acceleration is negative, the graph is going to be opened downward. The first thing, figure out at time t is equals to 0 if the body is moving towards right or moving towards left, वो कैसा जा रहा है ना? And accordingly, we work on the situation. If I try to interpret this over here, कैसा हो गया situation? The body started from the origin, went in positive direction. The body was moving with a velocity positive direction. U मान लो कुछ भी, yeah, initial velocity u. The acceleration was towards left, negative में था, because acceleration was downward direction. So a is equals to minus z in the negative direction. Body reached till a certain position, stopped, came back, वापस आ गया है ना. And in all these things, you might have noticed one thing: the graph was either in the first quadrant or it was in the fourth quadrant. The graph did not go in the second or in the third quadrant. What is the reason? Yes. The reason is time can never be negative. Time negative नहीं होता. हाँ, in certain situations we do manipulate to get the easy calculations, or else logically the time will not be negative. So graph would be either in the first quadrant. If it is a time graph, it is a time varied graph. The graph will never be going in the second or the third quadrant. You can also make a note of this one. The graph for the time variation will not be going in the second or the third quadrant. Reason being, time cannot be negative. Reason being, time cannot be negative. चलो, let me give you one more question. थोड़ा और समझते हैं with one more question. इसको थोड़ा और समझते हैं. So today's lesson is important in terms of the graph. Please do watch it if it is required for the multiple times, and do make the note properly. ना अच्छी बात. चलो, let us have a situation. एक देखते हैं. Some let's suppose if it is xt graph, I'm giving you the xt graph. Okay, so here we have a graph. ऐसा कुछ है. One graph is, let's say, like this. One graph like this. और एक क्या दे दूं? ऐसे रख लो, parallel, है ना? ठीक है. Let's suppose this is graph number 1, graph number 2, graph number 3, and then we have 4. Chalo, right, do the analysis of all these 4 graphs. सबका analysis करो, देखो what are they giving you, what are the information which you could gather from all these 4 graphs 1, 2, 3 and 4. देखो समझो उसको ना, you can pause the video and you can just sort of discuss, not discuss, sorry, you can think and you can jot down the information which you could gather from these 4 graphs and then unpause the video and walk around with me. फिर हम लोग साथ में जी चलेंगे, है ना? अच्छा, देखते हैं. Let's talk about the graph number 1. Graph 1 कैसा है? Slope is positive, body is moving towards right. Now it is how much? It is like what? It's a you can say the concave downward or the ball downward नीचे की ओर है. It means it is showing you a deceleration. It is showing you deceleration. As simple as that, है ना? Notice, check out. The slope is decreasing, so we have seen that. It is showing you deceleration. The body is moving towards right. Number 2, dx by dt is constant. Slope is constant. It is not changing, right? Slope of a line does not change. So dx by dt is a fixed value. It's a constant. What is dx by dt? Velocity. Velocity is constant. That means acceleration is 0. So body is moving with a uniform velocity. Number 3, you can see that the graph is going to open upward, है ना? So rate of change of slope, you can say rate of change of slope is positive. That means that implies graph is accelerating, you know, it's accelerating and acceleration is positive. Also at time t is equals to 0, the slope is positive value. It means velocity of the body is in the right direction, or you can say positive direction is completely upon you. Now let us understand the graph number 4. For the graph 4, the line is parallel to the time axis, which means the slope of the graph is 0. Slope is 0 and its position is not changing it with respect to time. Slope is 0 means velocity is 0. It means position is not changing with respect to time. That implies the body is at rest. ये सारी बातें हमने सीख ली है ना? We have learned all this basic understanding. We have this basic understanding about the graph. एक और देखते हैं ना. Let's see one more. Let's see that ऐसा कोई situation है जी ना. We have something like this. अगर ऐसा हमने ग्राफ दे दिया VT ग्राफ है ना. Let's say VT ग्राफ ऐसा को दे दिया ऐसा. Let's say this. Analyze करो उसको. Describe that motion. Meanwhile, I would just click this side. Describe that motion. Tell me something about the motion of that object. बताओ उसके बारे में थोड़ा बहुत. What is happening over here? Where is the body at the time t is equals to 0? How is it moving? क्या हो रहा है ना? कुछ भी ले लो एक वैल्यू यहाँ पे. Let's suppose कुछ भी ले लो. Minus v naught. हाँ देखो. All right. देख लिया आपने? हो गया एनालिसिस? ठीक है जी. Now let us do it together. At time t is equals to 0. At time t is equals to 0, that is over here, the body is having some negative velocity. The body is having some negative velocity. ध्यान से देखना है ना. The body has a negative velocity. Over the period of time, at this position, body comes to rest. At this point, velocity is 0 है ना. उसके बाद क्या हो गया जी? What happened after that? This is the situation where the velocity is positive. इस तरह velocity positive है and here the velocity is negative. Okay जी. Slope of VT graph is also positive. It means the body is having a positive acceleration. Situation कैसा है? At time t is equals to 0, so let's suppose something like this is your t naught, है ना? At time t is equals to 0, body has negative velocity. The body has negative velocity. If I want to interpret this, so let's say the time t is equals to 0, this is your 0 time. The body is having a negative velocity, means towards left. How much? V naught. Slope of this graph, that is dv upon dt, is positive. dv upon dt is positive. Slope to positive है. Slope positive means it is having a positive acceleration. It is having a positive acceleration. Positive acceleration means it is towards the right. It is towards the right side. So acceleration is in this direction. Now you see, the velocity and the accelerations are in the opposite direction, which means body will come to rest. Momentary rest also, but it will come to rest. लिख लो इसको. If the velocity and the accelerations are in the opposite direction, body would come to at least the momentary rest. Momentary rest पे आएगा ही. Now when I say at least, देखो, let's suppose when the body comes to rest, at that point only when the accelerations become zero by any reason, due to any reasons, then the body will become at permanent rest. But if the acceleration is existing in the opposite direction, it will come to a momentary rest and then it will change the direction of the motion. It means क्या हो रहा है? It will come to rest at this point, है ना? And then it will change its direction. It will change its direction. It will change its direction. And it will keep on going over here. So at time t is equals to t naught, over here it is t naught, body comes to rest. देखो, इस point पे the body is at rest. And after that, body started moving with a positive velocity. Positive velocity means towards the right, and it will keep on going. It will keep on going. इतनी बातें clear है ना? Now, in constraint of time, what we're going to do now? Speed, distance time graph, speed time graph, and few more questions I'm going to cover up in the next video. है ना? उसका करना जरूरी है. So maybe I would be making maybe 1 or 2 more videos on this. ध्यान से आप लोग देखना. Just watch each and every video of the graph. It's important. I mean, like, watch all the videos, of course, but graph again becomes very essential. I have told you the reason. Okay. Now, in the beginning, I had given you one question which was completely based on the IQ and the common sense, the way you observe things. You know? Look, these questions, when it comes to you, they always comes with a certain hint, and we just need to focus on that. So that actually tells you your concentration level also. Take it in a positive way though. Now, what I've told you, let me first erase this entire part. If you remember, I've told you that the weight of the truck with its driver was exactly equal to the capacity of the bridge. And the most important part of the question was, it was a long bridge. It was a long bridge. And here we have the truck with its driver. अब जो भी हो गंदा सा ट्रक बन रहा है ठीक है. So here we have the truck with its driver. बैठा था आराम से, it was like that. Now, I'm sure you guys know the truck's mileage is not too good. It could be around probably 3 to 4 kilometers per liter, or maybe 2 kilometers per liter. I'm not sure, but definitely it is going to be very, very less. Since it's a long bridge, it means by the time the truck reaches over here, it must have burnt a lot of fuel, right? It must have burnt a lot amount of fuel. 1 liter, 2 liter, 3 liter, it could be even 4 liter also. And approximately that's going to be equals to 4 kg. I'm not saying exactly, but approximately. So by the time it is almost about to reach the another end, it must have burned a good amount of fuel. Which means if the weight was W, it is going to be fairly, probably maybe 4 to 5 liters, 4 to 5 kgs, or maybe, lesser than the initial mass of it. So if an eagle sit on this truck, eagle will definitely not be more than 5 kg, right? So even if the eagle sit on the truck would pass without collapsing the bridge. Isn't that simple? So the idea was, the answer was hidden in the question itself, that it was long bridge. Long bridge means a good amount of consumption of the fuel, which will reduce the weight of the truck, and even if the eagle sit on the truck, that's not going to make a lot of difference, and the truck will pass through this quite easily without, meeting any accident. All good? So yeah, that's all for the day. In the next video, I'm going to come up with the speed, distance, time graph and all, and a good amount of few questions we're going to do. If required, I'm going to make one more video on this. But I would like all of you to go through these graph questions properly, do practice from the materials that you have. All right? So thanks for watching. Don't forget to like, share and subscribe. Also hit the bell icon to get the latest update on this channel. All right? So, ठीक है, मिलते हैं in the next video. Take care. Till then, keep learning and keep studying. See you guys. Take care. Bye-bye.